Hey guys, this is Chapter A, Section 2, Inequality Solving. So let's take a look at this top box up here. And essentially, inequalities are solved exactly like equations with one huge difference. And see, people forget this all the time. So let's see if we can't commit this to memory. Eyeball up that problem over at the right real quick and see if you can find a mistake. And since I don't have that much time with this deal, I'm going to go ahead and highlight an area for you. Right in there, see if you can figure out what's wrong while I switch to a pen. Well, let's see. How do you get rid of the negative 3? You got to divide by a negative 3. And if you divide by a negative, somebody taught you along the way, you're supposed to flip that guy around right there. So let me write that down for you. If you divide, and if you think about it, multiply and divide are basically on the same kind of level when solving equations and inequalities. So if you multiply or divide by a negative, and then keep in mind it has to be on both sides. So on that particular problem, if you're going to get rid of that negative 3, you got to divide both sides by negative 3. So something to keep in mind, something to commit to memory, and hopefully you won't forget that. So we're going to do a little warm-up here with some number line graphing, which we're going to do with the problems, but it's more important for section 3, but you got to kind of know how to do these. So this does sound pretty easy, though, and I hope this will be good for quiz questions, some gimmies. Notice for number 1, x is greater than 3. It doesn't say greater than or equal to. So what we're going to do is, to represent the fact that 3 is not included in the answer, we're going to put an open circle on the number line. And what kind of numbers are bigger than 3? X is greater than 3. On the number line, those are numbers that are to the right. So all these numbers going this way are bigger than 3. And so we're going to shade. And the shade represents all the numbers. So pretty darn simple if you think about it. So number 2 does have the equal sign with it. Means we want to include negative 5. Is it equal to negative 5? Yeah, it's part of my answer. So we're going to use a closed circle to represent that. And the good news here is, assuming the variable's on the left like it is on both these problems, the arrow or the symbol literally points in the direction you want to shade. So less than numbers that are smaller than negative 5 are this way. And all you have to do is shade. You're supposed to shade in that arrow at the end to represent that it keeps going on forever. And that's kind of important on down the line, in fact. All right, now, on a number line, there are an infinite number of numbers. Do I need you to put grid marks every single time and put 8 of them? No. So we know there's more numbers. So really, if you're supposed to do number 3, which is x is less than 2/5, all I need, or most math teachers would tell you, we just need you to label the spot on the graph you're talking about. So even if it's a fraction, 2/5 is still between 0 and 1, so it exists on the number line. So we know there's more numbers to the right that are bigger, and we know there's more numbers to the left. So we don't really need more than one grid mark. So no equal sign, that means an open circle, and the arrow points to the left, which means less than, and I'm going to shade that direction. So that's all you have to do for these. Pretty darn simple. Now, more good news, hopefully for you. Solving the inequalities is exactly the same as solving an equation, with the exception of what we just talked about a little bit ago. If you multiply both sides by negative or divide both sides by negative, you better remember to flip the inequality around, and that does make a huge difference. So, like normal, I always want to get rid of additions and subtractions first. So I'm going to take care of that 15 first. Off he goes. Okay, now remember, we're not writing an equal sign, so keep track. If it's less than, write less than. Total those guys up. How do we get rid of multiply? We divide. We have w is less than negative 14. Now be careful, right? There was a negative in the problem, the negative 28. But what did we divide by? We actually divided by positive 2. So there's no reason to flip that inequality sign around. So again, it's a number line, guys. Number line has an infinite number of numbers on it. The only one I'm really worried about is the negative 14. No equal sign underneath that represents an open circle. Numbers less than or smaller than or pointing that direction, shade that direction. And that's all she wrote. So we have an actual answer, and we have a number line graph to represent it. Okay, now I'm going to go ahead and throw in what's called interval notation right now. We're going to use this later on in the year. You can write it either way, the answers. This guy is called inequality notation. And inequality is a greater than or less than symbol. But here's how you do interval notation, and we're going to try to work this in. So the question would be, where is the shade on the left and where is it end on the right? So on the left, it goes forever to the left. So I'm going to write this symbol. So infinity means it goes forever. The negative sign means it's going to the left forever. You always put a parenthesis with that guy. Comma, where does the shade end on the right? It ends at negative 14. And we put a parenthesis if you have an open circle and a bracket if you have a closed circle. So we're going to try to work that in here. If you check out my notes, though, the notes are a little older, so any online notes won't have the interval notation. Hopefully we're going to fix that here in the near future. All right, number 5. So again, always want to start with the add and subtract stuff. So I'm going to get rid of this 3 first. I got negative 25 greater than or equal to negative 5n. So I'm about to divide by negative. So you know what? I'm going to go ahead and do it. That guy's going to get switched around because I'm dividing by a negative. Sorry about my terrible symbol. So divide those two guys, I get a 5. And 5's cancel, or negative 5's cancel. And I've got this guy. Now, my advice to you is this. The variable is not on the left side. I'm going to flip my answer completely around. And here's why it makes a difference. If you had shaded this original answer up here, the arrow's pointing to the left. But if you rewrite it this way, it's pointing to the right. So numbers bigger than 5. Well, numbers bigger than 5 are to the right. Close circle. Shade to the right. Okay, now here comes interval notation. And again, it's not in the online notes. So please try to check this out. If I have a closed-in circle, I use a bracket. And basically, we're asking, where's the shade go? The shade starts at 5 and goes forever to the right. Okay, and the infinity symbol always gets a parenthesis. So positive infinity stands for goes to the right forever. Negative infinity goes to the left forever. There we go. All right, problem 6. Don't let the fraction scare you. A fraction bar simply means divide. And what's the opposite of divide by 7? Well, times by 7. So that's what I'm going to do. Times by 7 on both sides. The 7s are gone. It'd be really tempting to do the distributive property on the top, but that's not why we used the 7. We used the 7 to get rid of the 1 on the bottom. And I got a 7r over there. So r's on both sides. So we know the next step is to try to get the r's or the variable on one side. So I'm going to move that whole 3r over there. And be careful of the fact there's a 4 left, yeah, but it's a negative 4. So keep those signs. Subtract these two guys, get rid of the 4. Okay, what am I dividing by? Am I dividing by negative 4 or am I dividing by positive 4? So I understand that the answer ends up with a negative sign in it. But I divided by positive 4, so there's no reason to flip that inequality sign around. Now, one more time, I'm running out of space here. I'm going to flip this answer completely around. So it says negative 1 is greater than r. So if I flip the answer around, notice how the arrow is pointing towards the r right here, and the arrow is still pointing towards the r. But if you write it this way with the variable on the left side, it's going to tell you literally which way to shade. So always a good idea. You don't have to do that, but a good idea. So there's my negative 1. This guy, hope you got it by now, open circle because it doesn't have the equal sign. And I want to shade this away because it's left hand. So here's the interval notation representation of this. But you got to think in terms of left, comma, right. So when you write these interval notation answers, it's what's going on the left. The left side is going on forever, the shade. So I use the infinity symbol, comma. What happens on the right? What ends at 1 or negative 1? And negative 1 is not filled in. Open circles get parentheses. Closed in circles get brackets. All right, running a little low on time here, guys, so I'm going to save the rest of this for part 2 video. There is a word problem coming up, so I know you're excited about that. So thanks for watching this one. Stay tuned for part 2.